10.1 Pythagorean Theorem, and we're using this with right triangles, and this will be a review from what you had in earlier grades. Alright, so this is all about right triangles. You can't do this Pythagorean theorem with any other triangle but a right triangle. A right triangle is, of course, a triangle with a right angle in one of the angles. Okay? The lengths of the sides of the triangle have a special relationship when it's in a right triangle. If you know two lengths of the sides, then you can find the third length by using the Pythagorean theorem, which is just a formula. Okay? In a right triangle, sides A and B are the legs. So this is a leg. Whoops. Let's make sure that this was going right really well. That was bad. Let's do this. Leg. Leg. Right. And this is a leg. Okay? So the A and B are legs, and then side C, which is always across from that right angle, and you can count that, and that's like taking it to the bank. It will always, always, always be across from the right angle. This is called the hypotenuse, and that will be side C. Why is my pen acting so weird? Okay, hypotenuse. All right, so like I said, always, always, always located across from the right angle. It is always going to be the longest side. Sometimes, however, students can't figure out which one's the longest side because it's really, really close. So that's why I say you can always bank on it being across from the right angle, even if you can't tell. Okay? But it will always be the longest side. It has to be. So if you figure up something and you get A or B to be bigger than C, then it's done wrong and you redo it. So when you're using the Pythagorean theorem, it doesn't matter which leg length you use for A or B. Does not matter. The only one that really, really matters where you put things is C. All right, so we are going to be using the formula A squared plus B squared equals C squared, C being the hypotenuse. So in our example, we have a length side at a 7 and a length side of 9, and there's my right angle, so this is my hypotenuse that we're looking for. So it says find length C. So you're going to take what you have and you're going to plug it in. Now I could start with a 7 as my A, or I could start with a 9 as my A. Does not matter. Okay, so I'm going to put in 7 squared plus 9 squared equals C squared. I just plugged in for A and B because that's what I have. All right, so then you actually compute it. 7 squared plus 9 squared is 81 plus 49 when you put that in your calculator, and that equals C squared. Now when you add 81 and 49, you get 130. 130 is equal to C squared. Now, in order to undo squares, we talked about this earlier this year, you have to take the square root. So I'm going to take the square root of C squared, and I'll take the square root of 130. You have to do to one side as you do to the other. So you have to do it on both sides. So when you do that, you'll end up just with C over here and approximately perfect square. So that's an approximation, and it's approximately 11.40. So when you put that in your calculator, it'll get you 11.40. And in the next section, we're going to learn how to simplify these radicals so that they're not in decimal form, they'll be in radical form. But for now, we'll just leave it as a decimal. Okay? All right, but sometimes you'll have to find the hypotenuse because they give you, you have the hypotenuse and they want you to find A. They gave me C. All right, so remember, C is always, always, always across from the right angle. This would be then A because I have B right here. So I'm just going to plug in to my formula. 3 squared plus, if you don't know what B is, B squared equals 6 squared. That's what C is. 6 squared is 36. 3 squared is 9. So now we have 9 plus B squared equals 36. If I take the 9 over, I have to subtract it because it's going across the equal sign. So I have b squared is equal to 36 minus 9, which happens to be 27. B squared is equal to 27, so I have to undo the square by taking the square root. So if I take the square root of b squared and I take the square root of 27, that's not a perfect square, so b is going to be approximately, and that's what the symbol means, 5.2. Okay, so if you have the hypotenuse, you're going to be subtracting. If you have just the legs and looking for the hypotenuse, you will be adding. Very, very simple. You can do it any which way which way they give it to you. If you have the hypotenuse, you can do it, or if you had the sides of the triangle, doesn't matter. Whichever way, as long as you have two sides, you can find it with the Pythagorean theorem. So we will be practicing this in class, and come see me if you have any questions. This should be a quick review for you because you've had this before, and I'll see you in class.